Alright folks, well last time around we talked about debuggers in general. Today I want to get into GDB specifically and looking at using that with some of the C and C++ programs that we're playing with. So we'll take a look at the features, the commands for it, how to use it. Maybe we'll apply it to one of the programming examples that we were looking at a few sessions back. So let's see what we can do here. It's not exactly the world's greatest debugger, but it's got most of the features that we're interested in, and it works in a command line environment, so it's suitable for our playing with SSH over the course of this term. Again, it works for C and C++ programs. It supports most of the core features that we want, and we'll just play with a few of the common commands as we go through this. So what I'm going to do, I think, is we'll run through the basic feature set, and then we'll pop up an example and try playing with it for real. So when you compile the program, if you remember way back when I was talking about the issue of symbol tables and compilers and variable names and whatnot. So the idea is when you compile a program, it doesn't actually need to remember what the variable names were for back in the original source code. It just has to remember, okay, well, I want to use the variable that I'd stored in this location. So it doesn't need to worry what the user was actually calling that variable. When you're working with the debugger, you want to be able to take the machine code, the executable code, and the debugger needs to be able to relate that back to things like the variable name, you know, to be able to associate what's in this spot in the code with whatever name we called it in the C++ program. So we need to be able to use a compiler, good grief, to be able to use a debugger effectively, the debugger needs to have that symbol table information available to it. So when we compile, we need to specify to the compiler, please include the symbol table information along with the .o or the executable file that you're creating. So the way we do that with the G++ compiler that we're using is that we throw in the -g flag when we compile. So you're going to do G++ -g and then whatever C++ file it is you're compiling. Then when you want to run GDB, you just start GDB and the name of the executable that you want it to work with. So myprogx or whatever it might be. And when we do that, GDB will spew out a whole bunch of stuff about, you know, all the usual startup information, and then it'll give you a debugger prompt. So by default, it looks like, you know, GDB in brackets. And so every time you see that prompt, you can start entering debugger commands. So actually, just off the top, when you want to quit, the debugger command to quit is actually just the word quit. Anyway. So usually when we're playing with this, we want to be able to run a program and stop it at certain points, breakpoints, so that we can take a look at what's going on in the program at when it reaches that point in the code. So usually this is done either by saying stop when you call function whatever, or stop when you get to line whatever in one of the different files. So in GDB, this is done using the keyword break. Actually, I think you can get away with just the letter B and it'll figure it out. So break, the name of the file, assuming that you've got multiple files that you're working with here, the colon, and then either the line number or the name of the function or method you want it to stop in. So break foo.cpp23 is saying, okay, I want you to stop when you get to line 23 in this file. Or, you know, break foo.cpp initialize is saying when you reach the initialize function or when you call the initialize function from foo.cpp, stop and let me enter commands. You can get rid of breakpoints as well by saying clear and whatever the name of the breakpoint is you want to get rid of. So we can set these up. We can start the program running. So you just, if you don't have any command line arguments for it, just type in run and it'll start running. If you've got a bunch of command line arguments you want to pass, you can do that as well. So run blah, 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 blah. And the program will start running and it will run normally. So it does the usual cins and couts and errors and whatever else is going on. And all that stuff gets printed to the screen or waits for the user to type in things appropriately until it hits one of these breakpoints. Well, I guess until it hits a breakpoint or it crashes. But at these breakpoints, again, it'll pause give you one of these GDB prompts, and you can start issuing more commands to look at what's going on in the program at that point. So you can do things like print the contents of different variables, so print and the variable name, or p and the variable name. And as long as that variable is visible at that point in the code, then you can print out its value. You can change the value if you want, using set, and then the variable name and whatever the new value is. So if you want to experiment with, okay, well, the value here is -1, I think it should have been 10. So change it to 10 and start the program running again and see if that actually solved the problem. If so, then you can go back and figure out why your value was actually -1 instead of 10 in the first place. However, so you can use p or print to look at a variable's value. You can also use x for examine to look at the contents of memory. So just give it the memory address that you're interested in. And of course, if you've got pointers floating around, then you can use p to print out what the address stored in the pointer currently is. So you can then use that address to go look at what's going on if you want to see what's in some place that a pointer is pointing. Now, quite often, once you get to that point and look around and see what's going on, you're going to want to step forward a few instructions and say, okay, what happens in the next instruction? What happens in the next instruction? So you can go forward one instruction at a time. And there's two ways to do that, either next, or just n, or step, or just s. So each of those will take you forward one more instruction. So they run the next instruction and then pause again. The only difference between the two is if you use next and the next instruction is a function call, then it just runs the function call as if it was sort of one single instruction. If you use step, it actually goes inside that function and starts letting you step or next from inside there. So it's just a question as to whether you want to treat a function call as a single thing unto itself, or if you actually want to go inside that called function. So next or step let you go forward one step at a time, one instruction at a time. If you want to just resume running normally, then you can use C for continue, and that will cause it to run until it hits the next breakpoint, or until it crashes, or until it reaches the end of the program. And if you want to bail out, you can just type in quit and it'll end. If you've got an active program, like if the program was still running when you paused somewhere in the middle of it when you told it to quit, then the debugger will probably ask you something along the lines of, oh, if you've got an active program, are you sure you want to quit? And just say, yeah, I'm done. One of the other interesting things that we can do with GDB is to examine what's on the stack right now. So to see which set of function calls is active right now. Again, if we are in function foo that got called from function blah that got called from the main function, then we'd like to be able to see that, so we can see what got us to this point. Or if we had some kind of recursive function and we're in foo that got called from 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 main, we want to be able to work backwards through that chain of foos and see what the values were for each of their parameters as they went along. So you want to be able to examine the different sequence of calls that have brought you to the spot you're in right now. You can actually do this when a program crashes while you're running GDB as well. So you type in backtrace, and that's what will dump the current stack collection onto the screen for you. So either if the program crashes, you type backtrace, and it'll tell you where you were, it'll tell you what line you were on, and which series of function calls brought you to that point. Or again, if you just run this normally as you're going, when you're at a breakpoint, again, it'll tell you how you got to this particular point. All right, there are a ton of other features supported with the debugger that we won't go into. Lots of other options, lots more you can do, but those are the core, right? Learn those first, get used to using them, get used to figuring out how they can help you in the debugging process, and start making it a habit to invoke this as a way of exploring what's going on with your code. All right, so those are the basic ideas. What we'll do is have a bit of a play with one of the programs we were working with earlier. Do you remember, I don't know, a bunch of sessions back, when we were working with makefiles, we had this idea of a program that was split into 4 separate CPP files. So we had data at the top, and then there was a list and a tree that used data, and then a program that used the list and the tree. So let's take that program and we'll just play with that in the debugger a little bit. So if you remember in our makefile, I think for that one we had as a couple of debugger options set, the wall and wextra, right, the usual ones. Well, if I want to compile for the debugger, I need that -g flag. So this is a good place for us to play with overriding makefile variables from the command line. So I want to run make, but instead of using the wall and wextra, I want to use the -g. So it compiles the program using this -g so I can use it with the debugger in a moment. So I'll do my make with -g as the compilation option. And it goes through, and you can see it compiled them all with -g's and linked them all with -g's. And so now we can go through and run gdb on our prog. And again, that goes through and it does the usual blurb about the licensing and whatnot. And so now I want to set a couple of breakpoints. Let's see, I think what we'll do is let's set a breakpoint for helps if I actually use the command. So let's set a breakpoint in prog.cpp on line 10. And let's set a breakpoint in tree.cpp. There was a print function in there called tprint. So we'll set, no, let's do it in insert. Why not? How about we do so we'll set a breakpoint so that if it gets to line 10 in the main program, it'll stop and let us enter commands. If it calls the tree insert function, it'll stop and let us insert some commands or run some debugger commands. So having done that, let's say run, and this is just going to run the program until it happens to hit one of those breakpoints. And so the first one that it hit was the that second breakpoint, the t-insert one. So we're in t-insert, and if I want, actually I didn't mention this in the slides there, but if you type in list, it'll show you the source code around the line that you're on right now. So we're stopped on line 11 here, and it shows you the handful of lines of code before and after the line that you're on right now. So you can get a look at, this is where we are in the code, just as a reminder. And I can take a look at the values of things, right? I can, oops, what's going on here? I can print I can print t size, I can print, max tree size. Again, as long as it's something that is visible at this point in the code, I can print out the value. Right, I can do things, see if I've got the right for set. Let's set t size to 2 or something like that. Yep. Do I need an equals? Never remember my syntax. Yeah, I need an equals. I think the slide was wrong therefore. So we can change the value of things. We can play with it. And again, I can use step to move along one instruction at a time, or I can use next to move along one instruction at a time. None of these are function calls, so it doesn't really make a difference right now whether I use step or next. Or I can use C for continue to let it run until the next time it hits some breakpoint. And again, this runs until the next time it hits an insert, and I can do the same sort of thing. If we just keep going, eventually we'll finish with all the inserts. I think it was doing 5 of them. And there we are, and then we get out of the whatever loop it was in the main routine and hits another breakpoint somewhere else. So this time it hit our lprint in the main routine. So again, if we do a list, we can see the code around there. So we're in main. We got to here, line 10. So we've got an lprint to print a list, and then a tprint to print a tree. If I do, again, an n, this is a good chance to look at what happens if I use next. It treats this lprint as a single instruction, and so the next thing I move on to is tprint. Whereas if I use s, it's going to take me inside tprint. And so again, if we take a look here, so now I'm inside the function that's printing a tree. So you can go through and play with this stuff as much as you like. Again, if we use backtrace, it shows me that right now I'm in function tprint, and it shows me that that was called from this particular line in the main routine. Right? So you can see where things come from. Right? You can see where you are now, and you can start investigating what's going on in your code. All right, and again, we can quit to get out of here. And in this particular case, I was in the midst of running the program, so it's just making sure that I really do want to quit. And you're done. All right, we will leave it there for now. I think next time we'll take a look at code profiling and code profilers.